Hi, everyone, and welcome to today's session, which is a pretty cool session, actually. It is actually taking the large language models like ChatGPT to the next level by integrating it to tools, plugins, and APIs, which can help it do a lot of other things. So you can imagine next time when you have a Jarvis-like system whereby you talk to like ChatGPT via voice, there'll be an API that converts your voice to text. And then from this text, you can just say like, help me buy a GrabFood lunch of chicken rice with no chili, something like that. And then this can be converted to an order, which you can then order through like a mobile app like Grab, and then the food will get delivered to you. So I think this kind of systems are within reach already, because if you integrate all these tools to the large language model, they can essentially perform this kind of actions for you. And the best part of it is that because a large language model like ChatGPT understands human intent pretty well, it's kind of able to facilitate getting those actions out in a very user-friendly way. So that's the benefit of integrating them together. And I think within this year, there will be at least 1,000 applications that combine LLMs with tools. So this is a very commercially viable product already. All right, so let's move on.
John,
today I'll be
yes. John, what happens if you order in like Chinese or in Hokkien?
Okay, so then that will be a requirement for your voice to text to decipher what language you are and transcribe accordingly. So currently systems like Whisper, the OpenAI Whisper, they are language agnostic. That means like what you can just say it and then they will determine the best fit language to transcribe it in. Yeah, so if those kind of systems are built
so are you saying that they will translate, or you're saying that they will be able to understand in the foreign language?
Yes, they will transcribe it. So if you talk in Chinese, the transcription will be in Chinese, and then you can feed this Chinese into ChatGPT, which will be able to convert it to your instructions in English or whatever language.
I don't want to distract, but like in Singapore, for example, people mix languages. Is that going to be hard? Like you could have Chinese, Hokkien, English all in the same sentence.
Yes, actually, this kind of crosstalk works for ChatGPT. So you can try keying in English and Chinese inputs together, and it will understand your intent. So I tried it before. So it's quite amazing. Thanks. Yeah, so this really, because of the flexibility of language, using a language model, it can be a very natural interface to link to this kind of tools, like to buy food using Grab or other applications. Or there's plenty of tools that can be integrated that really can help to benefit your lives. So let's begin to see how we can do this. So firstly, I will touch on this paper by Google. So Google has actually been quite a key supporter of transformers. I mean, they were the ones who came up with it. And this one was actually done by one of our fellow Singaporeans, Ite, who went over to Google. And this shows that by scaling up language models, it can do more and more things. Like you can see, it doesn't really solve like modular arithmetic at the model size of 10 to the power of 22 parameters. Okay, but suddenly, if you go to like 10 to the power of 24, it can suddenly solve modular arithmetic. So modulo is something like, what is 5 mod 3, which is like, what's 5 divided by 3? And then the remainder is 2. So this is modulo arithmetic, which requires like multiplication, division, and subtraction. So this one requires quite a bit of stuff that a typical neuron has difficulty doing, because like Dylan and I, we have tried doing modulo before. It's quite a difficult problem because the multiplication kind of thing is difficult for neural network to do. Yeah, I mean, as a proof of concept, you can go and try asking ChatGPT to multiply 2 4-digit numbers together. It's very likely to get it wrong. So somehow, if you have the model go larger, you can actually solve this kind of problems, which is quite cool. And what I would like to say is that there's quite a lot of interesting findings that they found that a larger model can, oops, sorry, wrong slide. A larger model can actually solve it better. But as I say in this slide here, there's actually quite some things that emergence can't solve, because you can go very big. Eventually, you'll be limited by like the amount of data available on the web to train. you'll also be limited by the amount of information you can sort of memorize, because implicit in the weights, you kind of need to train a lot of times in order for memory to be stored in the weights. It might be better to do some form of memory retrieval. So large can be better, but there are some limitations as to what can be better. And also being just large cannot solve the problem of multimodal processing, because if you are just primarily in a text mode, you can't really convert visual input, can't convert audio input. You kind of need other tools to help you to do this. So this is one of the reasons why this kind of tools, APIs or plugins can be so useful. So that's the next slide. So how many of you know this movie? Anyone? This I Know Kung Fu came from which movie?
Matrix.
Yes, Matrix. So in the scene, Neo plugs in one cable to his head, and then the program loads in the Kung Fu module. And then after that, he says the famous line, I know Kung Fu. So how the plugins link to LLMs actually is a very similar concept. You have something that already works. You plug it into like maybe ChatGPT, and then you give ChatGPT the ability to call it. And this means that it's able to do stuff like memory retrieval, run code on the browser. So those are the two plugins that OpenAI release for free. And it can also do a lot of other things like multimodal processing, which we will see in a live demo of Visual ChatGPT later. So I've loaded Visual ChatGPT. I'll show you how it's done. So what is the aim of integrating both of them together? Okay, one thing about LLMs is that it's very good at doing statistical prediction. It's able to do the next token prediction, and it's able to do it very well. In some sense, people think that it even understands like user intent. And that's actually quite a good thing, because you can use it to kind of dissect what the user wants, and then you can use it to link it to the tools that can do the job for the user, right? But LLMs have a fatal problem. And the fatal problem is that they are not very good at some stuff like math, logic, stuff that actually can benefit your life, but they can't even do a 4-digit multiplication problem properly. So these are the kind of things that you might want to just offload to a calculator, right? And also LLMs cannot really do non-text inputs that well. Okay, you still need to convert it in the primary language, which is in text. So what the APIs can do is they can probably handle the parts that the LLMs are not very good at. And this part will include like stuff like calculator and so on. So if you can fuse them both together, you get the benefits of both worlds. So this is actually a very, very powerful thing. So this is the summary of what I just said. And one other thing that I didn't say earlier is that the flexible and inflexible input format. So you think about it, like for example, your calculator, when you input in numbers to your calculator, you need to be in a fixed format, like 563 times 455. You need to key in each key in the exact sequence that the calculator wants it. This is not very user-friendly. So imagine I would like to say that, take the number 455 multiplied by 536 and give me the answer. I can say something like that. ChatGPT can know that these are the two numbers you want to multiply, and then pass these two numbers to the calculator tool, which expects it in a very fixed format. So this is a very powerful integration, because you can use the LLM or ChatGPT to capture your intent in a very flexible manner, pass it to a tool that expects it in a very fixed manner, get a tool to return the output, and kind of enhance the LLM's performance, because it can do stuff that LLMs are not very good at, like math. So one other thing about LLMs is that they are not very fast at learning, because if you want to train the LLM, you need to train it over multiple iterations of the training data. I mean, even you want to do fine-tuning, you need to train it over multiple epochs as well. It doesn't really adapt very well to real-world data. It takes a while to train. Like when you use GPT, when you use ChatGPT, is limited to data from 2021 and before. I mean, they might have increased the amount of data, but it's still limited by what data it is when it's trained. So if you want it to search the web, LLMs is not the kind of thing that you can use, but you can use a web search API that can help you get real life information, and then you can feed back the information to your LLM. So this means that you are able to imbue this learning part into your tools. Okay, how much of it we can discuss later. That's a very important question. Like, how adaptable can your whole system be? That's actually my research is on fast and adaptable learning agents. So we want to see how good this kind of integration can can benefit the agent's learning ability. I mean, one thing for sure is if your tools are learnable, if your LLM calls the tool, the LLM is sort of benefiting from the adaptability of these tools as well. Okay. Any questions for this slide? Okay, let's move on. So these are the key guidelines for what kind of tool integration should be. The main thing is that it should be learned without human annotation in a self-supervised manner, because the main reason is human annotations are expensive and very time-consuming. Okay, the second point is that integrating the LLMs with tools should not make the LLM lose its generality or generalizability to flexible human inputs. So the LLM should be still in a very flexible input manner, and it should decide for itself what tool to use. So how can we do that? We will look at some examples. So these two key guidelines were actually from the Meta AI paper. It's called Toolformer, and I believe it serves the basis of what this kind of integration with tools looks like. Okay, the other paper is Visual ChatGPT, which I'll be going through both papers as well. So let's just amaze you with what's possible already with these LLMs and tools. So one thing, this is from the Toolformer paper. I want to implement it on ChatGPT. You can try it out yourself also using the same exact text. So you just need to describe, like, it's actually quite straightforward. What you need to do is to tell the ChatGPT or the LLM to take on a certain personality. And in this case, the personality is you are a question answering API. And your main role in life is to add in this question answer prompt, okay, or rather this question answer function in order to find out the answer to a certain question. So when the input comes in like this, Joe Biden was born in what? All right, the question answer API will then like be able to tell like what is the thing that you should ask for. So in some sense, this means that you can sort of fact check whether this is correct, because by calling the question answer API, you will get the response from it, and this will like enhance the model's performance. So same thing for here. And this is the input text. So these are like few short learning. So we give it like 2 examples. Okay, we don't really tell the model here like how to use the tool. So that's one of the drawbacks of this kind of few short learning, because if you don't tell the model, so here we don't tell the model how or when to call the tools, let it learn by few short learning. Okay, there's an inherent drawback in this, because if we don't tell it like when exactly to use the tool, I mean, we could also have phrased it in this way: call the question answering API whenever there's a location or a person's name. You know, if you just phrase it like that, ChatGPT amazingly can do quite well, because it knows what's a person's name, it knows what's like a location. So if we just tell it over here, like we didn't exactly say that, okay, do person's name or location for question answering, we just give it some examples, and then we hope that it can learn from these examples what to do. So like over here, Singapore is a city in Southeast Asia. Hopefully it's able to tell like, okay, what is Singapore, the city, and what region it is, Southeast Asia. So this is actually quite cool, because it kind of worked few short, but actually it can work even better. So this was not done in Toolformer, but this was done in Visual ChatGPT and also in the OpenAI plugins. We can actually do better by letting the API know what kind of instances to call the tool. And somehow, even without any examples, if you tell the model, okay, call the tool whenever there's a location or when there's a person's name, it can actually learn without even this few short learning. So I've tried it myself and I was quite amazed with the results. So if you describe, yes.
John, can I ask a question? I'm a little bit confused. I thought that the way that ChatGPT was described, it was trained, right, through all of its next word prediction, RLHF, and all that stuff, trained, and then fixed. So, and then it goes into inference mode. So, are you telling me that it can learn?
Okay,
because I thought it couldn't learn.
This is not exactly learning. This is more like giving it the context. So when you
So what you're saying is that it needs to know about the API. It needs to have been trained and configured to be able to use the API. And this is just giving it some context. Is that what you're saying?
No, you can actually zero shot this. This is actually called few shot learning, where you just modify your prompt to ChatGPT. And as long as your prompt gives you some examples of input-output relations, GPT is able to generalize to a limited extent. And
No, but I
apply
mean for the like the QA API, it needs to know about that, right?
It doesn't. So in this case, you can just type this exact same text in ChatGPT with the trained model that OpenAI already has.
Right. So how do you reconcile that with the fact that it's not supposed to be learning?
Yes, so it is actually still sort of learning from the context that you give it. So because of the attention mechanism in transformers, when you give it an input, it can actually learn from the style of what you write in your input and can output in that kind of style. So this is something
What I
similar.
mean by learning is not the generic phrase learning. I mean, are weights changing?
The weights doesn't change.
Yeah. So then what is it learning? If it's fixed, how can it do new things that it cannot do? I mean, this is a question that comes to my mind.
Because you have attention mechanism, so you can sort of learn from the style of the earlier input-output relations here. In the attention mechanism, you can refer to the earlier text. So in that sense, you are giving it the kind of like sort of context for it to reference to, and then you can reference the earlier part of the sentence in order to generate the later half. So because you are grounding it in the context that you are giving here, so it seems like it's learning, but actually it's just referring to the earlier context. Yeah, there's no change of frozen weights in the transformer module. What has changed is when you do your attention, because of all your earlier tokens you have input here, your model is able to use these embeddings over here to kind of guide what to generate next. Yeah, it's sort of like you already generate 3 paragraphs worth of data. Your 4th paragraph will be conditioned on your first 3 paragraphs, because these provide the kind of grounding for what should your 4th paragraph be. Yeah, so in that sense, it's able to adapt if you give it the context. Yeah, does that make sense?
Yeah. Okay. Thanks. Yeah. Thanks.
Yeah. So as what I said, for this Toolformer, they didn't describe what the tool does. They just give it input-output examples, which is actually quite an inefficient way of learning. Okay, but it works pretty well already. It beat a lot of state-of-the-art benchmarks, but we could do better. So they did that better part in Visual ChatGPT. Here I'm just showing you how this was done in Toolformer, and it already works very well. In fact, just to give you a personal example, I was doing a healthcare project recently that requires like classification of patient harm, like from not severe to very severe. I realized that if you just type in the description of the severity, ChatGPT is able to kind of identify, like do the classification for you zero shot. I was very amazed because you just need to describe. So let me just clear everything. I think this is an important point to touch on. Last time when we do classification problems, you have like 2 classes here. Let's say X and O, right? So X is here, O is here. Last time what we need to do is we need to give it plenty of examples and let it learn the decision boundary to classify like that. All right, this is the traditional machine learning approach. Like you can use support vector machines to kind of learn the support vector and so on to maximize margin. Yeah, these are the like support vectors. We can draw it like that. This is the traditional approach. What I realize now is that you don't even need to give it the examples here. Okay, you can actually just describe in plain language. Okay, I have this region here. Sorry, I have some data here. You describe in plain language. My data A should be in this region, and my data B should be in this region. So you kind of describe the regions in plain language. And surprisingly, okay, LLMs are able to zero shot and do the classification for you. Which is really cool because it means that somewhere in LLM's training, the semantic meaning is captured already such that you are able to do this kind of zero shot classification, right? You try it out for your project next time, okay? Because I realized it works so amazingly for the healthcare classification. I was very impressed. So this is something that I realized you can use ChatGPT for, or you can use LLMs for. All right. Okay, all good. Okay, let's move on. So today's focus is on how to integrate with tools. So let's look at some other examples. So this is my own experiment. I tried to use like the Toolformer style approach to let it do math. So for example, you ask it to convert like some kind of plain text into a math. So like you can put it into a calculator program. So like ask it like, okay, this is the kind of inputs that we expect. And then you reply like the answer is this. Then I give it like 4 people have 3 rings each. How many rings are there, you know? And there are these rings in total. Then now the input that I give it to the model to try, I was like, we have $300 in the bank. We spent 102 on groceries, 30 on transport. How much is left in the bank? And amazingly, you see, it manages to take in the earlier context, and it even gives me the correct kind of equation that we need to key in to the calculator just on this. Right? So I thought, okay, maybe this is something simple. All right, let's try something even more difficult. So I challenge, okay, the compiler. I challenge it even more. I say that, oh, now we put 30% of the remaining money in the bank for charity. How much is left in the bank? So you look at the response here. You look over here. After spending $102 on groceries and $30 on transport, there is math 300 minus 102 minus $30 left in the bank. That's correct. And then after that, it does even the chain of thought prompting by itself. Then 30% of the amount, or math 300 minus 102 minus 30 times $0.3 is used for charity. Therefore, there is math 300 minus 102 minus 30, then minus 300 minus 102 minus 30 times $0.3 left in the bank, which is exactly correct. So this is what I would expect for a correct answer. And you can see that it can actually evaluate this using the tool. So this is the interface to tell it, okay, what tool to use in that bracket. So the tool is called the math tool or the calculator tool. And what's the input to do it? ChatGPT is able to give you that input directly just from a very flexible human-like input. So there's
John,
a lot of
can I ask,
potential for this.
is this math API, the math function, this is provided by OpenAI?
No, I just say that this is the math API. I did not provide any API to it.
But where did you tell it what the math API does?
Oh, it's at the beginning. So you can see over here, like you can call the API by writing math question.
Yeah, that's how you call it, but how do you tell it what math API does?
Oh, I haven't done the next step yet. The next step will be to take this input here and then run it through the tools. So the tool will need to see like, where is this math here? Okay, and then the tool will then output back the answer back and replace.
Yeah, so what tool is, so in this case, what tool is it?
It will just be a calculator tool. You can use an online calculator to do it, or there's a Python code to calculate it.
So you have to define the math API.
You have to define the math API, yes. That is
and
not
how do you so how do you get ChatGPT to use that tool? So it has to integrate, right? OpenAI has to support it with this release of ChatGPT, right?
Yes. Okay. So I didn't use the OpenAI plugins for this experiment, but what I would say that should be done is that OpenAI will take this output by the model, okay, and then it will run the API to run the inference for whatever the API is calling.
Yeah, okay.
And then it will then return the output back to the user. So this part needs to be done by the OpenAI part, okay? Or you can just take this text that is generated, run it through your own inference model, because you can just...
I get it. Okay, I get it. Thanks.
Correct. So what I'm testing out over here is I'm just testing how flexible it is to generate the input required by these APIs. And it turns out it is very flexible. Of course, there are some limitations, which I will cover later, but overall, I was quite impressed with the flexibility that this ChatGPT could convert user intent from just plain English into fixed inputs that the model wants, that the API wants. Right. So as the proof of point here, like, why do we need this kind of APIs? If we ask ChatGPT to convert this math expressions and calculate it out itself, you can see this is what happens. It calculated the result of this multiplication, 102 times 538, as 54996. But the actual result is actually 54876. So there's some problem with the multiplication using language model. But if you have a tool that can do math, you feed in the right answer, which is 54876, and replace it in the earlier part where you ask it to do this multiplication, you get perfect results. So you can see the potential of this already. It can potentially reduce the flaws that ChatGPT has by imbuing it with better functionality. Like, you know, one of the other things that ChatGPT doesn't do very well is it doesn't do fact retrieval very well. But if you can match your user intent to a database of facts, and then you can retrieve the relevant facts, maybe using some form of embedding similarity. Like you can use vector similarity to find out what are the facts that are most relevant to your intent. You can then output a very factual response. So it somehow can solve like the hallucination problem of GPT as well. If you have a database of facts, of course, how you get the database of facts is another problem, right? But these are potential stuff that could be done. Right.
Actually,
so,
John, I have a question. How
yes.
How do you know on the previous page that the argument to the math API is correct? You seem to be saying that the answer it computes is wrong, and if you have a tool called math, a calculator, I can just feed it the arguments that it computes. But how do you know that that's correct? You don't know, right? If it can hallucinate in computing the final answer, doing the multiplication, how do you know it computed the argument?
Are you talking about the inputs? Are you talking about the inputs to the API, like over here?
No, yeah, exactly. How do you know that's correct?
Correct. So that part may be wrong. So that is a limitation with the integration process. Yeah, we need to basically make sure that when you want to integrate it with the API, there will be very low chance of confusion with ChatGPT to interpret the inputs. So I will have a section on limitations later. I have explored some of the limitations. You cannot do certain things for this kind of inputs. Yeah, so I will talk about it later on.
Okay.
Okay, of course, there's no paper like doing the limitations for all this. I was just experimenting with it on my own because I thought it was too good to be true if it can work for everything. So I tried some failure cases. Later, I'll show you some of the failure cases. Okay, so this is Visual ChatGPT. Can I just check how many of you heard of Visual ChatGPT? Can you just like put a tick or thumbs up? Just want to know, like, okay, just take a look at what it's doing now. You can do like Kenny Age of image. So Evan has heard of it. How about the rest? Have you heard of it? Okay, Goku has heard of it.
I have not.
Okay, but you can take a look at the visualization here. It's pretty cool, right? I mean, you can interact with Visual ChatGPT, and then it can like sort of do the images for you, like generate an image. You can talk to Visual ChatGPT and say like what is described in the image and so on. Yeah, you can even say make an image in the style of this. They can do style transfer as well. Yeah. So how does this work? Later we'll go through in detail as well. So this is the rough flow chart. You have a GPT query. All right, there's this thing called a prompt manager that kind of interprets your input. And then what happens is that this prompt manager has also all these foundation models that does like stable diffusion, question answer for the image. So you can do like control net, which is like generate an image with certain parameters controlled. Like for example, I want to generate like, you can say that in this image over here, I want this part to be the mountain and then this part to be the sun, then you can use control net and do it. Yeah, which is quite cool because you can then control like exactly how you want stable diffusion to be. So control net is a really cool thing. I intend to cover this in another session because I think control net is really very cool. Yeah, but anyway, these are the kind of foundation models you can use for ChatGPT or LLMs in general. You pass it through this prompt manager, and then this prompt manager will then decide, okay, based on this query, okay, look at this condition on the predicted depth of this image. So I should call a depth processor to get the depth. All right, after that, I should then fill in this with like control net to kind of like generate the flower. Yeah, and then in the end, to make it to a cartoon, you can do some form of style transfer. So there are different foundational models that are called for all this. And using an iterative process, okay, called the chain of thought prompting, which I will cover in detail later, you can actually get ChatGPT to give you like what tool it should use at each step. So these are the two things that ChatGPT did. Actually, three things, because in order to generate this this kind of depth map, you also need to call a foundation model for it. So you can call various kind of tools in order to generate whatever the user asks over here, and it can be a multi-step request, which is really very cool. Okay, so at the end of it, Visual ChatGPT will then output like this flower in the cartoon form. All right, then another amazing announcement that happened about 3-4 days ago is the Wolfram Alpha plugin. So Stephen Wolfram is someone who is really quite ingenious. He created his own language to do computational problems like math, physics, chemistry, plotting. So the Wolfram Alpha language has been around for 40 years. Okay, and actually they also have their own way of using plain text to convert into the language. But you can make it even more flexible by using ChatGPT as the input. So for example, ChatGPT will then process like, I want the distance from Chicago to Tokyo. So this will be the input to the Wolfram API. And the Wolfram API will then say that, okay, this is the query that we want, all right? And then it will break down into like certain words, and then it will come up with like, oh, what's they retrieve from their database and so on. So all this is done like at the back end. And what the user will see is just like the distance from Chicago to Tokyo. They'll show a map with a distance here. So if you're interested in what are the things that the Wolfram Alpha plugin can do, feel free to go to this website. Okay, it's called ChatGPT Gets Its Wolfram Superpowers. And there's like a very, very long blog post describing what can be done with Wolfram Alpha. And it's pretty amazing that they actually okay, what's amazing, of course, is the LLM and the tool plugin compatibility. But what's even more amazing is from the announcement that Wolfram Alpha and ChatGPT can be integrated together. That happened in January. And now in March, we have the product. So in just 2 months, we have a product, a working product of ChatGPT integration with Wolfram Alpha. And this is never before seen in the history of tech product creation. I mean, you normally take a few years to iterate or a few months. Now we do it in 2 months. That's really very fast. And
actually, John, can I ask you a question? Why are you so impressed that it's so fast to interface? Wolfram Alpha existed, ChatGPT existed. All they need to do is provide an interface to each other. That really doesn't sound very hard, to be honest. Why are you so impressed?
I think this interfacing part was a problem sometime back. I mean, you had to use natural language understanding, some form of rule-based kind of ways to
but that's what ChatGPT solved, right? So ChatGPT was amazing. It understood natural language. But once you understand the language, interfacing to a tool is quite easy, I thought. I mean, maybe I'm wrong.
I mean, that's an afterthought, right? Before ChatGPT came, honestly, do you think it was so easy to interface?
But I'm not saying ChatGPT is not amazing. I'm saying the interfacing is not amazing. ChatGPT is amazing, right? And Wolfram Alpha itself is amazing. But to interface amazing things doesn't sound that hard, actually.
This thing about Toolformer only came out sometime in January or December, like 3 months ago only. So whatever I described to you in the Toolformer paper, this was an ICRR paper.
Yeah.
So
yeah.
This just came out, and then all the apps already came out already, which
right.
is like,
right. So that should tell you actually interfacing is not that hard. Because
yes.
if everyone is doing it, it's actually the barrier should be quite low. The other thing I'll point out is that we're amazed about plugins, but WeChat has had this for years. WhatsApp is way behind. In China, they exactly all the examples you gave, they do through WeChat. They order their food, they order their taxis, their car shares. They even get bank loans on WeChat. So WeChat has all these plugins already. What's amazing is the natural language part of it, right?
I mean, of course, we can downplay the amazingness of it. Personally, for myself, I didn't expect tech to progress so fast. So this is something amazing in that aspect for me. But of course, if you think that like interfacing is an easy problem, then this is nothing amazing.
It is. It's just specification, actually. It's a little bit of code and specification. That's interfacing. Yeah, and with ChatGPT, it'll become even easier because they can write the code for you.
Correct. Yeah, so it really depends on what your background is. If you really think interfacing is easy, then this is nothing amazing. But what ChatGPT has enabled it to do is it can interface with arbitrary tools, like almost with zero-shot learning or few-shot learning. And that is really something that is quite interesting because a lot of people can be doing their plugins now. And all you need to do is just specify what's your input and what's your output and what use cases or when to use your plugin. And GPT can like kind of figure out whether or not to call your plugin. So that is the amazing part. It can few-shot or zero-shot interface with an arbitrary tool, even without any if-else statements. I think that part is quite interesting. Okay, any other questions? All right, if not, let's just think about what kind of APIs can be potentially interfaced. And this is actually very, very cool, because as you know, he's regular logic. So like and you can use like a very flexible input format to give like a logic tool format. Like for example, for the logic, they actually expect a certain kind of format. ChatGPT can actually interface it like that. You can do fact checker, okay, to just check whether a source is good. If check whether a source is legitimate, maybe based on another database of facts. Yeah, you can do visual, video, touch, audio processing, even taste processing, I guess, if you have like a tongue-like sensor. So all this kind of things which text cannot do, you can use the API to do. And you can then converse with the interface or converse with ChatGPT in a text manner, and you can do stuff like editing your pictures. Next time, we can even do this for PowerPoint slides. I recently saw like a use case of ChatGPT in like the Unity game designer. The person just typed in like, I want to create 100 1x1 blocks randomly around a 3D field, and then all the blocks just get generated. It's like really cool. You can just stack in plain text, and then the kind of stuff gets created for you. Like even for Blender, a 3D object creation, you can describe what kind of objects you want. I want a vase with the middle like narrower, like half the size of the base, and then the vase just appears. So if you can interface it with like even PowerPoint slides, you can just describe, I want to create a slide on information, on a PowerPoint presentation on information theory covering the following points, and then the slides will just appear. So Microsoft is integrating like ChatGPT into its Office products. You can treat the Office product as a kind of API also, like that'll be the output. The output is a PowerPoint presentation. Yeah, you can also do web search. Like you can just get what you need, like your question answering. You can just take the relevant parts and then search the web, and then the web will return back the result, which the LLM or ChatGPT can then interpret and give you a response. External memory, this is very interesting because this is actually my kind of research. I kind of think that memory is very powerful because we can use memory to do the prediction of the future. Like how do I navigate from point A to point B? I kind of need to retrieve some memory in order to go over there. So if you can retrieve the exact sequence of path or actions in order to take from point A to point B, I've essentially solved the navigation problem just using memory alone. And if we can infuse this kind of external memory into ChatGPT by some form of preview, it can actually see if the memory is adaptive. You can actually sort of learn from experience, because if you store the experience in your memory, you retrieve the memory, you can sort of say that the ChatGPT or the LLM in general is learning. Okay, there are some limitations to this, but this is an exciting prospect. Okay, there's knowledge where you can infuse it to some form of, there's this project called CYC that like tries to give you some form of like reasoning in terms of like why should like water like go into water, like why will water go into water vapor when heated? Then you can go through, retrieve some list of facts and so on. So this kind of knowledge web can also be interfaced with ChatGPT. Coding too, you can ask ChatGPT to come up some code like, I want to compute the first 100 prime numbers, and then after that, when it comes out the code, you can just say execute it. So this is actually out already. This is in OpenAI plugins. One of the plugins is a coding tool. You can execute the code that ChatGPT generates on the interface itself. So when you get the plugin, all right, you can actually do this for free. All right. Chess playing program. Okay, so some people have used ChatGPT to play chess. Right? Of course, it's not designed to play chess. Okay, it's meant to do text inference. So you can actually use the API to connect it to like AlphaZero, and it can play chess for you. So these are quite exciting possibilities. Yeah, just pause here for a while. Any of you can think of other APIs that you can foresee being interfaced? You can just say it out here now. Like anyone? Yeah. Okay, no worries. We can talk more about it in the discussion. Let's move on because kind of have a lack of time already. So another exciting prospect is this thing called Neuro-symbolic AI. So as you know, in the past, like the good old-fashioned AI, people have been trying to use symbolic AI, which is like first order logic, second order logic, to kind of describe the world. And it's very hard to scale up because like there's so many arbitrary terms to do logical inference over, right? But now with LLMs, it's now a very exciting prospect because you can use the LLM, the flexible input, to feed in these symbolic systems and then let the symbolic system do its inference. Like people talk about causal reasoning. You can do causal reasoning using symbolic AI. You can say like A, when getting an effect B will cause C. Yeah, so you have all these chains that you can use logical inference to do. You can sort of have some form of causal interpreter if you want it to do causal reasoning. You can have the symbolic system do causal reasoning, and then you can explain it back in plain text, which is a really exciting prospect. And I think this should be looked into more because I think this combines the best of both worlds, like the good old-fashioned AI, the symbolic part, and the flexibility of an LLM. You can combine both of them together. I know of at least 3 projects working on this neuro-symbolic AI. I hope to invite I hope to invite one group of them to share on this session in the future. Yeah, like what they're doing, and they're using some form of LangChain, which is a software or framework to integrate LLMs with external tools. Okay, so LangChain is very, very popular now. Okay, so if you haven't heard of LangChain, you can check out the documentation. It's very easy to create a tool interface. Like you just need like maybe 20 lines of code, maybe. It's actually very, very efficient. Yeah. So like Visual ChatGPT, it uses LangChain. So we'll go through a bit of the code later. So this is a step in the right direction. Like Wolfram Alpha plugin is sort of neuro-symbolic as well, because Wolfram Alpha does some form of symbolic manipulation to calculate math as well. Okay, next slide. So this is the work, learning fast and slow, that I just thought of like sometime in December. This is done with Prof. Mehu and I. And I think this work actually can be linked to LLMs and plugins as well. Okay, why? Because like, okay, although LLMs learn very slowly, like if you learn an action condition on the go here, you can treat this as the LLM action prediction. You can use LLMs to predict an action. I mean, people have done using transformers to do next action prediction, and it works very well. So this can be the large language model. We can also use a transformer for this part. And this part where we retrieve like trajectories from like point A to point B by sampling possible futures in the memory, this part can be like the API that does memory retrieval. And then when it sends back the action here, this action then can override. Although I would like to say that an LLM probably would learn like slightly slower than using like other forms of models. Like for example, over here I just use a MLP, multi-layer perceptron. It learns very fast. LLMs will take a while to learn because there's more parameters. But you know, there's some parallels with this, and I think this is very exciting, like because like I feel this kind of goal-directed learning is the way ahead. And action prediction, like even without rewards, this is actually a very powerful idea, because by doing action prediction, you can sort of already model the world in some sense. You model what kind of action you need to take from a start state to an end state. You are sort of modeling like how your hand, like maybe from here go to here. If you can model the action that your hand takes to go from start state to end state, you are sort of modeling like kind of the future possibilities of where your hand would be without needing to worry about like the probabilistic part. Yeah. So this is something quite cool.
So John,
yeah.
what you're saying is that the slow part is like a tool that the fast part, which is the LLM, would call.
Yes.
That's nice. I like the idea a lot. Cool.
Yeah, I mean, this is the link. But of course, I would say that LLM learning is still quite slow, so we need to improve that. But
yeah, of course, yeah.
Yeah, if this is the case, right, then I would say that an LLM with plugins can potentially be adaptive, because this work, learning fast and slow, is very adaptive. It can adapt very well to like a changing environment. So if we can imbue this in, maybe we can have learning systems with LLMs.
Yeah, exactly. Yeah, that's what I was thinking. That's why I like this. All
right, next. Okay, so we go into the how it works session. So first, we talk about Toolformer. Okay, this is where it first started. I think sometime in December, Toolformer came out. I can't remember the exact date, but it's only very recently, right? So this Toolformer, as what I demonstrated earlier, you can just give it some examples like that, and then you give it your own input here, and then out comes the output, and it can learn it quite well, even without telling it like when should you call the question answer API, it can learn from like sort of the examples you give. Okay. And they even do this thing called fine tuning. So what they do is they actually fine tune the LLM on the data set with the API call tokens already inserted. So like all these tokens over here, they have already inserted it in the tokens. So like, for example, you can treat as your input-output pairs. Okay, I mean, granted, they didn't use something like that. I mean, in the code, they just did something like that, QA dash, and yeah, so the format is slightly different, but the idea is similar. Okay, they actually call the function, okay, in terms of text. So by training the fine-tuning to the input and output relation like that, you are letting the model know when exactly to output those texts that corresponds to the API call. So if you do this fine-tuning, you don't need to have this few shot prompt every time you call the model. Because why you don't want to have this is because of money. Like every time you key in the tokens in like OpenAI, you need to pay for the number of tokens you generate. So if you can do some form of fine-tuning, which you cannot do for now for ChatGPT, maybe in the future you can do. If you can do this kind of fine-tuning, you may be able to do away with this few shot prompting. Then it will already know when to call the API just from this fine-tuning itself. This is a very exciting prospect. Okay, right now, I would like to say for the OpenAI plugins, there is no fine-tuning step. All right, it's just simply just sending a prompt at the beginning of the session to tell the ChatGPT which APIs are available and what do they do. That's it. There's no fine-tuning, but in the future, this might be the case, especially when there's like a million APIs, possibly have a million APIs worth of might need to be done in the future. All right. So one thing about their paper is that they only keep the API call tokens that improve performance over baseline models. So actually, this is a bit of a hack because they want to beat state-of-the-art models. But in actual fact, like if you want to do this kind of thing, it can be very expensive because you need to run the API and you need to compare with the output of you not running the API and you see which output is better. So this is a very expensive process to train. So this probably was done to beat the state-of-the-art benchmarks, but you may not need to do this step. You can just do the fine-tune with all the API tokens inserted, regardless of not whether it benefits the model. So you can see this is exactly what is done here. So let me just give you a brief idea. So this is how the API call is done. So this is the embedding of the API call. And then this is the API call with the result. Okay, so Li plus is the input with the call and the result. So it's something like that. You have your wiki search plus the result. Okay, so this is the whole call with the result. And then your negative example is basically the loss. Okay, this loss is the next token prediction loss, which is the cross entropy loss actually of the next token prediction. So this is the empty sequence, which means that you don't call the API at all. And this is you call the API, but you have nothing written. So it's something like you call calendar, but you don't give it this part here. This is Li minus. So what this means is that if your Li plus and Li minus, if let's say this gives you a loss that is like higher than a certain threshold, okay, maybe the threshold is 1, okay, the higher the loss, the lousier it is. So if let's say you not calling the API, so this Li minus is not calling API, or API gives no result, okay, if this loss is higher than this Li plus, which is calling API and getting a result, if it's higher than that loss, that means it's probably useful, right? It means like I predict better the next token compared to the ground truth. So only when this is above a certain threshold, then you put the API tokens in, and then you fine tune on that data set. Okay, so this is what they did for the model. So you can see that like what are the kind of things that are useful, like wiki search for locations, calling calendar, these are useful. Question answer is very useful. Calculator, of course, very useful. What's not so good is like this. You are here, catch this fast train to success. Then you can see that, they Googled for fast train, and then like fast train became like an album. So, over the train to success, you are referring to not like saying, I take the highway to success. So in this case, the API call is not useful, and you can see that this is below maybe the threshold 1. So you don't include this API calls in your fine tuning. So this was what Toolformer did. And I think, oh, hang on a minute. Did I pause my screen share? Okay, let me redo the screen share because I accidentally paused it. Okay, can you let me know if you can see my screen now?
Yes.
Okay, yeah, that's good. So this is the case of how Toolformer did it. And you can see the results. Okay, let me just touch on the results briefly. So a 6.7 billion GPT-J model can outperform a 175 billion parameter model, okay, just by using tools. And you can see over here, the main thing, like you can see, like Toolformer with the tools disabled, okay, it actually even performs better. So like having the model with, okay, sorry, Toolformer disabled means, okay, what happens is that you have this thing over here. You have a fine-tuned dataset on dataset C, which is a subset of the original dataset that has benefits for tools already. So Toolformer disabled has been trained on the dataset that, you know, if you use the tools, there's some benefit. Okay, so this is just a baseline to compare with the Toolformer. Okay, which is basically if you call the tools or the API, you can see that there's a performance upgrade in question answering, Google RE, and T-Rex. Okay, these are all like data sets. And all this over here, you can see that the performance increase is great. Like this is over 20 points increase. And even GPT-3 didn't do very well in it. So you can see a lot of the models like intelligence can actually come from the tools that they use. I mean, they use like calculator tools, which obviously help a lot for math kind of data sets. You can see over here. Look at the improvement here. Look at this improvement. It's like almost 30-point improvement, which means that, you know, transformers suck at math. I mean, we have established that earlier. So if you put in stuff that can do math for you, you can basically make the transformers output more reliable. So this is actually a huge thing that you can integrate it with tools. Yeah, and not too long ago, language models were only taught to output text. And this idea of linking it with tools is really a groundbreaking one. I think this will be one of the key ideas in this century will be LLMs with tools, because there's so many possibilities you can do with it. All right, so you can see even GPT-3 doesn't do that well. Even with a higher number of parameters, it just doesn't do as well. Tools make a huge difference in the performance. Okay, so I will not go through the rest of the results. I think this is the main idea. Tools make a huge performance increase. And now we go through Visual ChatGPT. So one reason for why we want to do like things like Visual ChatGPT is like what we talked about earlier. If you want to do things like multimodal processing, it can be very hard to tell the input in a non-text manner. Like imagine I want to create, like over here, I created this on Bing image creator. You can try it out, it's free. All right. It's actually using DALL-E, so you can play around with it. It's very cool because this means that it's actually a public release of DALL-E. You know, when OpenAI released DALL-E, it was actually closed. But now when Microsoft does the Microsoft image creator, they are releasing DALL-E to the public for the first time. So I really liked it. I played around with this a lot, and the images are not as impressive as like DALL-E 2 or Stable Diffusion, but DALL-E can create a lot of like template images quite well. Like for example, the starting image of this slide deck, the LLMs in the center and some random stuff around, was done using Bing image creator. So I'm not to advertise for Bing, but stuff like this, it will be very hard to do in the image input space. You need to sort of give some form of instruction, and the instruction is best done in text, because I think it's a more or less a universal language to do a lot of things. Like for example, when you learn things in school, you typically learn from text, and also you learn from videos, of course, but text is the way to tell you the instruction. And if you can tell the system the instruction in text, and it can do stuff for you in images, that is really cool. Like you can generate this apple in space with just some text like that. This is enabled by tools. So OpenAI hasn't released GPT-4 officially, the full version of the multimodal GPT-4. But what I can expect is that it has already interfaced with tools quite extensively, because you can use these tools for multimodal processing. You can do in this kind of domains. Image, audio, video, touch, taste, maybe, you know. This is a very powerful thing, because you can then do interpretation of various images just by using text. And in fact, you can convert this video into text also in order to do some form of analysis. So by using text, your main domain of interpretation and discussion, you can do a lot of things with all these various domains. Okay, granted, it's not the way that the brain does it, I believe, because it's too verbose for a brain. If you do this in the brain, I think you will run out of energy very fast. But at least it enables us to do a lot of things that we once thought it was in the sci-fi movie. Like, for example, Jarvis in Iron Man, you have this AI system, you can interact with many different components. I think it's very possible now with LLMs and tools. You just need to wait for someone to create it, or you can create it yourself. All right. So next we have chain of thought prompting. Okay, so just a quick show of like hands here. Anyone here heard of chain of thought before? You can just raise your like thumbs up or something. I just want to see like how familiar you are with chain of thought. Okay, we have about 3. All right, so chain of thought is actually a way to improve the performance of a large language model by asking the large language model to think. Okay, I know it sounds very contradictory because like you just need to ask it to think by itself and then it can improve the performance. Okay, the key thing is you can ask it to like explain what it's doing. Like for example, if you use this like robotics model, like can you bring a fruit flavored drink without caffeine? So this is called the secant model actually. So if we were to do this, okay, and then we generate the actions, it may not know exactly what to do because like fruit flavored drink without caffeine, what drink is it? So if you ask the model, like just prompting the model, so it's a very simple way of prompting. So this is the input, right? Can you bring a fruit flavored drink without caffeine? Then you just need to type in the word explanation ... And then the large language model will generate the explanation for you. This is generated by the large language model. The user has asked for a drink that is fruit flavored and does not have caffeine. I will bring the lime soda. Whoa. So it has decided that the drink that it needs to bring is a lime soda. And then from there, you can then plan the actions. Find the lime soda, pick up lime soda, bring it to you, put down lime soda, and done. So like for my learning fast and slow, actually, I thought this kind of chain of thought prompting to find actions to do like hierarchical planning or rather sequential planning would be very exciting because these are the sub goals. And then you can just basically condition on the sub goals to do the actions. So I thought this way of doing planning is quite interesting. And chain of thought can actually help with the improving the output quality of large language models by simply asking them to explain or like ask them what's your thoughts. And then if you can verbalize the thoughts, it can actually use that as the context to generate better predictions. And it's really such a simple idea. And yeah, I'm just surprised it works. Yeah, so you can also prompt the LLM to think of whether it should use tools. So we use chain of thought prompting to ask the LLM, do you need to use a tool? Do you need to use a tool? Okay, I'm at this step of the image. Okay, I created the depth match. Do I need to use the tool? Then, oh, the user asked me to generate a cartoon of the flower using the depth. Yes, okay, I need to use a tool. I need to generate the flower using control net stable diffusion. Sorry, using control net. Then I generate the flower. Then I get a realistic image of a flower. Then you ask the model, do I need to use a tool? And now the model says, yes, I still haven't converted into a cartoon. I need to use a style transfer kind of tool. And after I generate the flower in the cartoon form, then I ask the model, do I need to use a tool? And the model can now say, no, I'm done. I got my output generated as requested by the user. So surprisingly effective. You can just use this chain of thought prompting to keep asking the model, do I need to use a tool? So let's take a look at how this is done in Visual ChatGPT. Okay, before we go into Visual ChatGPT, I need to introduce you to this thing called React. So React came out in 2022. And this is synergizing reasoning and acting in language models. And basically what is done is like, if you give it a question like this, who is the Navy US Admiral who served as ambassador to the United Kingdom under which president? It's a very complicated search. Okay, but you can then ask the model to do chain of thought, like, what's the thought? I need to search David Kanoff and find the US Navy Admiral he collaborated with. So then you ask the language model, what is the tool I need to use? So in this case, we are giving it the search tool to search the web. So with the search tool, it came up with the response. The observation is the response of the tool itself. So the response of the search, the web search will come back like that. Then you can ask the model, what's your thoughts of this response? And then you can say, oh, the US Admiral David Chanoff collaborated with, the US Navy Admiral David Chanoff collaborated with is this guy, William J. Crowe. So then you can ask the model, because this is, you need to find out the ambassador to the United Kingdom under which president, right? This is the last part. So then you need to ask the model, do I need to use a tool? And the model said, yes, I still need to search for who is William J. Crowe. And then you get this answer from the internet. And then after that, what we can do is we can ask the model, what's your thoughts of this observation? And so the model can say, the President William J. Crowe served as ambassador to United Kingdom. Sorry, the president who William J. Crowe served as ambassador to the United Kingdom is Bill Clinton. So we've gotten the answer here. And then the model can just use like this, actually called not using a tool. You can ask the model can just say, I don't need to use a tool. I already have the answer. And the answer is put in the finish tool. I mean, the finish tool is like no tool. Okay, so what will the user see? So if you are the user, you key in a question like that, you run the React agent, your answer that you will see is just Bill Clinton. Okay, you don't have to see all this. Okay, but of course, if you want to see, you can also output the intermediate steps. But just by prompting it, the thought, the action, which is where you ask it, like whether you want to use tools, and the observation, you can do this kind of chain of thought over sequential kind of tool retrieval and tool usage. You don't have to use the same tool. You can use different tools. And this action over here is done by the large language model. The large language model will have access to all the tools that it can use, and it will then choose the action that is best to get the outcome it wants. And that's really cool because, yeah, this can work actually 0 shots. Just by the tool description, it can work already.
Sorry, question.
Yes.
So all this entire, which part of it is the prompt?
The prompt is this one at the start.
No, but
Okay.
you need to teach the model to do like retrieval or to use tools, right? That part should also be done with prompting, right?
Yeah, so the front part here will tell you the list of tools and what tools there are. So I have a slide to show that later.
Okay.
Yeah, but this React manner, the React mechanism is the fundamental thing behind Visual ChatGPT. So I'm covering React because this thought action observation is kind of fundamental to a lot of thinking processes. Have you heard of this thing called the OODA loop? Observe, orient, decide, act. Something like that, right? So I mean, it's similar to like, what's your thoughts? What's the actions you do? Then after you act, you think about orient yourself. What's the observation again? Yeah, sorry, the observation is what comes back to you. Yeah, so I think this is quite similar to the OODA loop. Yeah, OODA loop is used in the military a lot to like decide what you should do based on a certain observation. I thought this was
like the Singapore equivalent of the, what was the other thing we use? This is US equivalent, right?
Yes. Yeah, I don't know about Singapore or US, but basically this is a tool that is used in the military quite a lot. Yeah, this kind of decision acting cycle. Yeah. Okay, any other questions on this React? This is the key thing that you need to know in order to know how Visual ChatGPT does it. And in fact, when OpenAI does the plugin, backend is using something very, very similar to this. And you know what? You can run this React agent in probably just like 3 or 4 lines in the LangChain. You just need to call the LangChain React agent. And all these are done backend. Like how the agent does the top one, this is prompted by the LangChain agent backend. So it's just giving top one and ... then the model will generate this one. Then after you give action 1, then the model will generate the action. Then this observation will be provided by the LangChain agent. After the tools have been used, this will be provided to the agent. Then the LangChain agent will then ask the LLM, what's your next thought? Okay, what's your next action? You know, that kind of thing. Yeah. So yeah, this is done all in the back end of this React agent. And it makes life very easy for developers. If you're interested to do this LLM plugin with tools, just use LangChain. It's really very easy. The only thing you need is money because you need to call the LLM, which is provided by OpenAI, which costs, I think, 2 cents per 1,000 tokens. So yeah, that's the thing that you need. Other than that, the React framework using LangChain is already very well documented. And this is something that can be done immediately for most businesses. Okay, let's move on. Okay, so this is the overall workflow that I created. It just illustrate like how this is done in Visual ChatGPT or like even in the OpenAI plugins. So you have a user input here. Okay, the user input can be text or can be non-text. Okay, if it's non-text, the prompt manager will need to distinguish like, okay, what do I need to do? So in the Visual ChatGPT is very easy. You just need to create a new file name for the non-text data, like picture, you need to store it in a new file name. You need to just ensure that it has a unique file name. And over here, for the non-text data, you need to give some form of dialogue for the LLM. You need to tell it like, the human has given you a file titled abc.png. Yeah, then the AI will then, so actually the text for like non-text data is very simple. It's like the human will be like the prompt manager will type in like a text like that, human given you abc.png, and then the AI will then say receive. So because this whole like LangChain React agent is done in a conversational style, so you need to do human AI, that kind of thing. So this is done by the prompt manager to say that this has been done. Okay, but if you don't need to do a non-text, I mean, if the data is a text, then what will happen is the human will just give like human text, and then the AI will then, this how you will query the LM to generate the AI's data. So this one is for non-text data, and this one is for text data. So essentially, we are doing a ChatGPT-like conversation, just that if there's a non-text data, the conversation will be generated by this prompt manager. There's a higher level that will just tell the AI, okay, the human has given you this file, which can apply for audio files as well. Yeah. Then backend, there's this storage where you store all the non-text data, right? Then after that, we had to use the chain of thought, which is what you saw just now, the thought, action, observation. You ask the API whether or not, you want to call, so you ask the LLM whether or not you want to call the API based on this chain of thought prompt. And in this case, I say yes. Okay, yes, you go to the right. No, you go back to the left. No, you will just output back to the user what the LLM thinks should be the output. Okay, if yes, okay, then this is the interesting bit. The prompt manager again, okay, needs to execute the API. So just now, prompt who you were asking, like, how is the math API called, right? So there needs to be a second layer, like a manager to like interpret the text output of the LM. Like, for example, if the LM wants to call like a certain tool, this prompt manager needs to execute the tool and return back the output to the LM. So this part here is done by the prompt manager. Or
that makes sense. Thanks. Yeah.
Sorry, so you're saying something?
No,
So
that makes sense. Yeah.
I want to ask this prompt manager another language model.
Okay, the prompt manager is just some rules. So it's like, the React agent that I was talking about earlier. The whole React agent, like the interfacing of the like thought, observation, all these are done by the prompt manager. The prompt manager will prompt the LLM to output the next step. Yeah, so all these are done by a certain set of like rules. Like it's already a sequence, like the thought, action, observation. The prompt manager just needs to enforce it. And if the agent acts on a certain API, the prompt manager needs to go and tell the API to do it and get the data from the API back and feed it to the LLM.
I wonder if it's a rule-based is enough, because you need to need to be able to interpret your input. Then based on that, decide what's the next step, right?
Yeah, you can see that most of the part of the API input is all done by the LLM. LLM will tell the prompt manager what's my input and what API I call. All the prompt manager needs to do is be an obedient soldier and just execute it. I mean, of course, you can put some safeguards there.
According to the flow chart here, prompt manager is the first one to get the input,
right? Yes. So the input will be processed by the prompt manager first to determine whether or not, is a text or non-text.
So its only job is to decide whether it's text or non-text. Oh, okay.
Yes. So this one, if you look at the code over here, this actually is done using some rule-based also. Yeah, like for Visual ChatGPT, if the user creates the upload image, then that will be a non-text data. If the user types in a text, then that will be a text-based data. So all this can be done using rule-based. You don't need to use LMs or the prompt manager.
I see.
Yeah. So of course, this prompt manager thing is It's really a higher level structure. It's meant to just prompt the LLMs using chain of thought reasoning and execute the LLM's actions if it wants to use tools. So for example, it wants to use the API, the prompt manager will then call, maybe this is the math API. Okay, then we go to the next step. Okay, after it gets the math API, what should we do? Okay, the math API, you have gotten the answer, like you have calculated like 532 times 456. It goes back to the prompt manager. Okay, and okay, this is the part that it needs to process the data again. If the data is a non-text data, like for example, if you do image, like let's say you generate an image using Stable Diffusion, it's a non-text data. The prompt manager will then need to generate the dialog saying that, okay, API has generated this image. And then the LLM will then decide, what to do with the image. Okay, because LLMs cannot take in vision input as tokens for this LLM. It's all text-based. Okay, so this prompt manager will then need to do the same thing as what the user input did. You need to tell the LLM, okay, the API has generated this image, or API has generated this audio, all right, and then pass it as text to the LLM. If the API generates text, like for example, you saw the question answer API earlier for the president of United Kingdom, right? That one is all done by text. Then you can just feed in the entire text of the API into the LLM over here. So this prompt manager serves a very important role because this is the bridge, okay, between the user and the LLM and the APIs and the LLM. So it helps to process the data in that sense by maintaining a conversation of human and AI to the LLM. Okay, and then the LLM will then ask, like you ask the LLM, what's the action that you should do? And the LLM now says, okay, I've gotten maybe my math calculations. Okay, there's no need to call any more APIs. I can end. So I will then output to the user. And then over here, the prompt manager will then package the data into the end user format so that it appears nicely on the user screen. Like here's the generated image. Those are done by the prompt manager. So in the Visual ChatGPT API, Visual ChatGPT document, the prompt manager is not just the LangChain React agent actually. There's some code as well in the Python file that does this processing into the table. Okay, so this one, they use this software called Gradio to display the table. So, you need to interface with that. And this is done using rule-based via the prompt manager. Okay, let's look at the Visual ChatGPT paper. Okay, this is actually a lot of words, but what this does is it just shows you the overall workflow. So this is the initial prompt that we give the React agent. So the initial prompt is quite simple. First, you have some principles. You need to tell it to take on a certain personality. So like, you are Visual ChatGPT. Your name is Visual ChatGPT. It's something like creating a robot. Like a robot born into the world, then you tell the robot, okay, this is your job. Your job is to invoke the vision foundation models to understand pictures. And you are very strict to the file name. Okay, I mean, they try to prevent hallucinations like that, all right? And then this will be the reasoning format you use. Okay, this is actually not in the prompt. This one is because of the React agent. Okay, the React agent takes in this format: thought, action, action input. Yeah. So yeah, like if you want to use the action, like what's my input that I use? Okay, like if I want to do like question answer, what question do I want to ask? That's the action input. Then we have a list of tools. Okay, so the prompt manager, okay, will basically take each vision foundation model and categorize it, like what's the name of the tool, how should you use the tool, like when you need an answer for a question based on an image, this is the question answer tool. What are my inputs and outputs? So input will be a comma separated string of 2 representing image path and the question. So all this is actually done using the LangChain LangChain format. So you can specify your tools in the LangChain tools function. Yeah, so this is actually not done using LLMs. This is all done using the LangChain interface. Right, then you can also give an example of like, when should you call this tool? So this is optional. If you give it more examples, it will have a better performance because it knows exactly when to call the tool. But you can see that just by specifying the usage alone, you can actually use the 2.0 shot already, which is the same kind of observation I got when I did it for my medical classification data set. It could classify the patient harm 0 shot just by the description of the patient harm. So this is a very powerful tool. You can just describe what the tool does, and somehow, ChatGPT is able to do statistical inference and find out based on your plain text of how the tool works, whether or not it should call your tool in a certain scenario later on. This is actually very powerful. Okay, then you can see that pix-to-pix is another kind of tool. You have the same thing, name, usage, input, output, and example. So if you look at the OpenAI plugin format, right? This is actually the kind of similar things that you do here. Of course, OpenAI does other things. They do like this kind of authentication. I think it's OpenAuth or something like that. So basically, they use another way to like specify the usage, which actually is very similar to this Visual ChatGPT. And you can see that, as I said earlier, compared to Toolformer, this is actually more versatile because Toolformer does not really explicitly describe the usage details. It didn't tell like, how can you do the question answering or when should you call it? But over here, we have this usage parameter here, which already specifies in plain language when should you call the tool. So it enables it to learn faster, even without any examples. So, this with the advent of ChatGPT, we have to rethink how we do classification. Maybe we don't have to use so many data to define a decision boundary anymore. Maybe you can just use plain language to describe your decision boundary. And that is really very powerful.
Sorry, can I clarify? So the principle, right? Are they inbuilt in through just prompting or?
It's just prompting.
So then isn't there a risk of like being jailbreak?
Yes. Yes, there is. Yeah, so this is one of the ongoing problems that will need to be solved as people try to jailbreak people. Then you need to put more defenses on it. I will discuss also how I think we can prevent jailbreaking as well.
Yeah, unless we can find a way to inform the model, like different prompts has different level of
yeah.
You get what I mean, right?
You can basically make this a meta layer so that this cannot be modified. So you can use LLMs. The top LLM will have this meta instruction, and the bottom LLM interacts with the user. So once the user interact finish, it goes to the meta LLM, and this meta LLM will then process the user input to make sure that the user doesn't jailbreak.
So it's another model. Okay, we'll
Yeah.
talk about it.
There's one slide on this later.
Right.
Okay. So this is the interactive prompting using chain of thought, and really what you can see is that you have the history of dialogue, which is like the human AI dialogue that we talked about earlier. Okay, the user, okay, when the user keys a query, okay, if it's a file name, okay, the prompt manager will do the human AI thing to give it like a file name. Okay, and then the prompt manager will do the cycle. What's my thought? What's my action? What's my observation? Prompt manager will do the cycle here. Okay, and if let's say ChatGPT needs to use a tool, all right, then ChatGPT, okay, will need to use the prompt manager to execute what the visual foundation model should do. Then the prompt manager will tell back ChatGPT, okay, what's my file name, and then like you can even ask the user for clarification. This is amazing. Like one of the tools that can be used is called Ask User. So the ChatGPT can actually prompt the user, can you be more specific? Can you tell me what you want to do about this image? Then this actually can be considered a tool as well. So if your tool is called Ask User, then ChatGPT will then return an output to the console to ask the user, can you specify like certain details? So I think this is quite cool because this creates a more conversational style interaction with the AI chatbot. Okay, and of course, also there's this whole history of reasoning, which is the thought action observation. The whole list can be condensed in some memory, and then you can replay this memory every time you ask the AI to decide what's the next action or next observation. So all this is done using the prompt manager, which is a combination of rule-based in the Python notebook as well as the LangChain React agent, mainly the LangChain React agent. So if you use LangChain React, you more or less get Visual ChatGPT like more or less out of the box already. Okay, so this is the overall flow. Okay, I think I more or less described what has been done. So for example, you upload this image, the AI will then respond, receive. This is done by the prompt manager. Okay, then replace the software in this image with a dash, make it look like watercolor painting. This one will then be asked with the prompt manager using the chain of thought. Over here, you can see, like, do I use the VFM? Yes. Okay, execute, replace something from the photo. Okay, and then we get this thing here, which is fed by the which is basically fed by the prompt manager back into the system. So this is what has been done. So after that, the model say use another foundation model? Yes. Okay, then instruct image using text. So we get this. And then we get this answer over here. Okay, over there, after we ask the VFM, is there any more things you want to do? The VFM, the LM says no. Okay, so what will happen is that we will then output the, okay, where's this 9A50? So this one is here. Okay, so this replace something here is, so I actually drew the arrow wrongly. This replace something 2dB 9A5A 2dB. So this instruct image over text, make it like watercolor painting. This part here is actually, I believe, the same as this last part here, because you know you don't need to output anything, so they just output the replace something image out here. So yeah, I think the arrows are correct. So you can see that the overall flow of Visual ChatGPT is just keep querying it. Do you need to use the tool? Do you need to use the tool? Yeah. So if you go back to Toolformer, you can do the same thing for math. So do you need to use a tool? Then maybe the prompt manager can just insert the math result into the part where they call the math function. Yeah, so it's something that can be done. Okay, so this is a very interesting thing. So for Visual ChatGPT, there's this prefix that you add on to the model, like before it does any prompt. Okay, it tells the character of what Visual ChatGPT should do. So you take a look at what this is. Visual ChatGPT is able to process and blah, 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 blah. So I just want to highlight this part here. You can see it's very strict to the file name and will never fabricate non-existent files. And is loyal to two observation outputs rather than faking the image content and image file name. Okay, anyone want to tell me why do you think they want to put this here? Okay, actually, this is because large language models like to hallucinate a lot. So they try to use this to prevent hallucination. And I mean, well, it kind of works. So quite interesting that you can ask it to stop hallucinating by just saying that you must not fabricate the files. And, you know, somehow it works. So this is something that is quite interesting that Visual ChatGPT did. This whole Visual ChatGPT code is open source, by the way. So you can try it out on your own by just going to download from the GitHub and you can just run it.
So I'm just curious, if the fabrication is so easily being solved by just prompting, then does it work in other settings as well?
I think it's difficult because in this case, it's a very specific prompt. The specific thing is you cannot fabricate anything with this .png or anything with file name. So if you talk about fact checking, like everything can be a fact. So it's very hard to tell the model, you know, you shouldn't fabricate facts. I shouldn't fabricate lies because it doesn't know what's a lie and what's a fact. But over here, if you just say that you must be very strict to the file name, I think it's understandable because like all these file names are like your context. You can just repeat them again.
Are you talking about a situation where there are conflicting information from its training data? So it doesn't know which one is more authentic.
I'm talking about a situation whereby you have certain facts, like for example, I don't know, yeah, I mean, give you an example of fact, 3 is bigger than 2. You know, certain statements in English language can be very objective, but certain statements are quite subjective. Like Republicans are better than Democrats, you know, that kind of thing. What is a fact? What is not a fact? It's very hard to tell the model, like what is, because everything has different interpretations by different people. So in this case,
but even this you can still prompt, like you say for opinion, it's not a fact, you just teach it, right?
Okay, so this file name thing is quite exact. So it's like it's a very clear context.
Okay, I see. It's fine. I'll go back and try myself.
You can try to prompt it. I mean, this you can do with ChatGPT. You don't need GPT-4. Okay, I've tried this. You can try to prompt it yourself, see how good you can get a model not to hallucinate. But this system is actually using Text DaVinci 003. Yeah, so Visual ChatGPT uses this model. It's not even ChatGPT, so it's just GPT-3, and it can already work already. Okay, so this is the tool usage format. Okay, you can see that this is the tool format that you give it. Okay, thought, action, input, observation. So actually, you do give it this format as the prompt. All right, and then when you have a response to say to the human, you use this format. Thought, do I need to use a tool? No, then your response here. Okay, so if you need to use a tool, then this is the format. So it's actually giving the instructions of what the React agent should interact with the Visual ChatGPT in this prompt. So this is really quite interesting because you can just tell the ChatGPT, this will be the order of things you will execute. So you can tell if you want to use the tool, do this format. You don't want to use the tool, then use the other format. And then this is the suffix, which is the end of the prompt, end of the initial prompt. You are very strict to file name correctness. Again, you know, they emphasize again, you will remember to provide the file image name loyally if it's provided in the last two observations. So you can see that they not just repeated the do not fabricate one time. I think they repeated it like 5 times, 4 or 5 times in the initial prompt. It's just keep reminding the model, you must not fabricate, you must not fabricate. Yeah, it's quite funny. But yeah.
So does it actually make it like more effective by prompting the same message multiple times?
Maybe. I haven't done experiments on it, but I mean,
but if that's true, it sounds like really similar to how human learns, right?
Yeah,
we also need
funny.
to like reinforce some things in order to remember, like,
yeah, I guess
better.
we repeat it more often, you will kind of encourage the attention mechanism to focus more on those words as well. There's, I think, some kind of, I mean, we could do some experiments on it, like how many times should you repeat to get it to reliably output. But it does seem like repetition helps to play a role. Yeah, I don't know how much of a role. I didn't do the experiments here, but you can try it out. Right. So this is like the conversation history also. So it's like we have like a chat history, which is provided by the React agent. So we actually, this is the input for React, which tells it like where to insert the agent's memory and where to insert the input. So this curly brackets are the format that format that LangChain takes in order to insert in like user input or history. And you can also use like agent scratchpad here. These are the kind of stuff that LangChain provides. So yep, this is more or less the initial prompt. And the prompt manager will then execute the action using the action input that is given by Visual ChatGPT's LLM. All right, so this is how we run text and upload images. Okay, I'm just showing you the code here because I just want to highlight certain parts of the code. So for example, over here, run text is basically like you enter stuff in Visual ChatGPT. You can see that this is text-based input, and the thing about the agent is that the agent will receive the input as to what your text is, and then the agent's output will be like basically written as like the response, which is what you ask the agent to do. Yeah, because this rest is what the agent gives. Okay, so human will give the text and the AI will give the response. Okay, in the event of an image, okay, we upload an image to Visual ChatGPT. What will happen is that, okay, the human provided a figure, name this, the description is what. This information helps you understand this image. So this description over here, okay, is actually automatically called the image captioning API. So the image captioning API will interpret whatever image you give the model, and the model will have some idea of like, okay, what image is this? Okay, the same thing can happen also after the API generates like an image. This image captioning will tell the LLM like what kind of image is it. So this will be the human description here. And the AI description is very simple. It's just receive. So you can see that while we do the thought, action, observation kind of thing, we also maintain a human AI kind of conversation, okay, which is stored in the memory of the agent. Okay, so the agent has memory of the conversation that it had with the human. So these are very cool stuff. And yeah, it's very interesting how they got Visual ChatGPT to work. This was created by Microsoft and they released it open source. So, all right, let's stop the share here. I'll just show you how Visual ChatGPT works in real time. So let's go to my Visual ChatGPT here. Can you see the screen, by the way? A thumbs up if you can see.
Yep, the turtle.
Yeah, y'all can see the screen. Okay, so what I did was I actually went to Jupyter Lab. Okay, I went to Visual ChatGPT and clone this GitHub here, which you can clone it. I put the link in the video also. Yeah, so you can clone it yourself. You basically have this file called Visual ChatGPT, okay, which you can then go in here and you can create your environment. Okay, activate the environment, install the requirements, which is a lot. Okay, and then over here, I just ran Visual ChatGPT with 2 APIs. One is called image captioning, and the other one is called text to image. Okay, there are other things that you can run, but it will because I'm using a CPU right now. I mean, if you have GPU, you can run everything. Okay, but you need a V100, I think, to run. I think 4 V100s to run all the vision foundation models because it's quite GPU intense. All right. So this is what you need to do. Okay, so I already have ran the code here. I've ran the code just now. Okay. And then what I did was I already did the first input. So when I ran the code, okay, I'll show you this Visual ChatGPT without the API. So I highlighted certain parts of the code just now earlier. So this is like the prefix that you give it, the format instructions. Yeah. So one thing is you need to kind of put your API key here, OpenAI API key, which I didn't put here because of course it's chargeable, but your OpenAI API key will link to this one here. So you can see like your usage. Like every time you use the Visual ChatGPT one time, you will incur some cost. So like just now I generated the image of a turtle. I incurred 3 cents. Yeah, so that's the that's why I say all these tools you can already do it. It's just whether you have the money to pay for the token generation. So yeah, but if you get the OpenAI API key, you start off $18 for I think like 3 months, and then you can just use it. If not, after that you need to pay. Yeah. So I'm still on my free credits. Yeah. So anyway, let's go to the where's my here. So I create me an image of a turtle flying in the sky. So if you go back to the Visual ChatGPT, you can see that over here, do I need to use a tool? Yes, action generate image from user text. So they call the API, and then the prompt manager will say that, okay, I process text to image, and the input text is this. Okay, the observation is this. Okay, do I need to use a tool? No. Okay, because I've already generated the turtle for the user, I don't need to use a tool. So here's an image of turtle flying in the sky. And you can see after you finish the chain, okay, the chain of events, that's why it's called language chain. Okay, after you finish the chain, what it does is that, okay, it basically says that, okay, this is my current state. Create me an image of the turtle flying in the sky. This is from the human. This is from the AI. All right. And this is the current memory. Yeah, actually, the state and the memory is similar in this case, but for other cases, the state and memory are different. So let's try another input. Okay, you want to ask it anything about the picture? Anyone? Yeah, you can just tell me what you want. So maybe I just pause for half a minute. You want to ask it anything about this picture? Okay, I asked first. Okay, so
Breed
what
the
color
turtle
is
with a snake.
say again?
Breed the turtle with a snake.
Greet the no. I'm not going to generate another image because it took me 2 minutes to generate this image.
The shell is at the bottom.
Yeah. Sorry. What do you want to ask?
No, are you saying is there something wrong with this turtle?
No, as in, I'm just asking like what do you want to ask about this image so I can type in for the next prompt or Visual ChatGPT.
Oh, I see. Why is there a shell at the bottom?
Why is there a shell at the bottom of the turtle, right?
Yeah.
Okay, so when you click enter, you run the run text part of the code for Visual ChatGPT. We can take a look at what's running here. So, where is it? Here. So you can see that over here, why is there a shell at the bottom of the turtle? So, and the current state will be like that. And then what will happen is we actually don't really call any API. I think they didn't need any tool at all. Let me see. I can't remember where it was. Output text. I think it's here. A green circle. Did it call a tool? Let's see over here. Yes, it called a tool. It called the photo description tool, which is like describe the photo. All right. And then over here is the tool return a green sea turtle in the ocean. So after that, the language model say I don't need to use anymore. So the AI will then respond. The turtle in the image has a shell at the bottom because it is a sea turtle. Sea turtles has shell. So you can see that the tool gave it useless information, right? A green sea turtle in the ocean. I guess maybe it's useful information because it tells it's a sea turtle. So then it uses the LLM's inherent knowledge about sea turtles to answer you that, shells protect them from predators. That's why it has a shell at the bottom. So you can see this is the human AI chat here. Human AI, and then over here, this is the AI. The turtle in the image has a shell at the bottom because it is a sea turtle. Yeah, so this is what we ask. So this is the conversation. you can see that the state here also includes like the image source and everything. Yeah, so there's more stuff in the state, but the memory in terms of the LLM conversation is much more truncated. It's just text only. All right. So okay.
By the way, that's a hallucination, right? Because what it said is absolutely not true. But anyway, I guess that's not the point here. You're just trying to demo Visual GPT.
So which part is not true in this answer?
Are you sure sea turtles have shells on the bottom?
Oh, you're saying sea turtles doesn't have shells. Oh, okay.
Yeah. Not the bottom at least.
I get it. Yeah, so of course, if you have more tools over here, you can ask it to, like generate a sea turtle shell that is like in the form of like a spaghetti or something like that. So I didn't have stable diffusion or control net enabled here, but if you have it, you can ask it to do it. Maybe I just ask it a question that doesn't require a tool. Like maybe you can ask it, what is 2 + 2? This doesn't require any tool at all. So let's just take a look. What is 2 + 2? 2 + 2 is equal to 4. So you can see over here. Does it need a tool? No. Okay. So let's also like maybe show you like how the uploading is done. So let's say if I upload something, I upload my profile picture maybe. Yeah, let's upload my profile picture inside this. So this is my profile picture. I uploaded it. So it's given received. So let's take a look over here. So when I upload my picture, okay, what it did was, did it give anything? I think it's just putting here. It didn't even call LangChain. It just basically say human has provided this figure, the description of the figure. So they really ran the description API, a man with glasses and blue shirt. Okay. So when you call this API, actually you don't incur any token cost at all. You only incur a token when you like run the LangChain prompt, because all this incurs the tokens. Okay. When you do all this, actually it doesn't, if I'm not wrong, it doesn't incur any cost, because all this image to description, all these are done locally. Right, so the AI just needs to say receive. Okay, so we can also ask it certain things, like you can ask the AI certain stuff like, what color shirt is the person in image /448d2a95.png wearing? Yeah, so you can ask it stuff like that and it will give you a response. So we can see they're wearing a blue shirt. So you can see over here, this is basically, do I need to use a tool? Yes, get photo description. So again, it gives you the output text. Okay, and you can see that, do I need to use a tool? No, because like here is already given a blue shirt. So this gives you a question like, what if the image description doesn't give you the color of the shirt? Then how? Okay, over here, a man with glasses and a blue shirt, right? Let's try to ask it a question that it does not give the observation for. So let's ask it like, what is the background of this photo? Because the photo description didn't give the background, right? So let's ask, what's the background of this photo? So let's take a look what happens here. The background of the photo is a white wall, so it's wrong. Okay, so you look at it here. So when it calls the image captioning API, a man with glasses and blue shirt. So over here, you see it kind of hallucinates here because it does not get the information it needs from this API. Of course, there are other APIs that could describe with a certain context. Maybe it can help to answer this question. But you can see that if it's not corresponding to the description of this image, there's some limitations. You cannot get the information you need if the API does not give you that. Of course, you can solve it with more APIs, but this is just an illustration of like what are the limitations that this thing cannot do.
Can I check which model API are you using?
Which, sorry?
Which language model API you are using?
This is the Text DaVinci model.
You mean the one you are using?
Okay, let me just search. Okay, so
because the API is provided by you, right?
Yeah, so it's using conversational React description, and I believe it is the Text DaVinci model. So I have to see. Okay, I have to see where the model is. Yeah, so maybe
because I would expect GPT 3.5 or 4 at least if it can't get help information from the descriptor, then it should tell you I cannot give you the information. This
Oh,
is this
interesting. Yeah,
this
I think over
hallucination is
here
too much.
it might be using ChatGPT because it's not specifying the model in this code. Yeah. So yeah, you can specify the model from OpenAI. Yep.
I think the output is not good because at least what it can do is to tell you it doesn't have the enough information to tell you to answer your question.
Correct. So I'm only using like 2 out of the 24 vision foundational models. I believe there are some vision foundational models that can actually, you can query the image. It's called image question answering. You can ask the model like, okay, what color is the wall in the image? And the model can then respond, the color is blue. Okay, but I did not give the question answer model here. This is only the image description vision foundation model. So
right,
but
I'm talking about in the event that the language model does not get enough information, it should at least tell you it cannot answer your question. That's my point. So the hallucination here is too much.
Yeah, so it kind of didn't really say it. So this is something that can be improved. So I just want to highlight this part here because this is the limitation of LLMs with tools. I mean, although you can integrate it with tools, the fact is if your tools cannot solve it, you are still stuck. Yeah, I mean, it's limited by the capability of the tools and also the capability of the LLMs, because like as what Prof. Manhu mentioned earlier, like sea turtles maybe don't have shells at the bottom, but if the LLM doesn't know that, then it will answer wrongly. So I mean, while this is quite impressive, like there are certain flaws that still needs to be improved. But if you can give it the right tools, right, actually, like even this one can be solved. Like you can give it the tools about like what does a sea turtle have shell? Maybe you can give it a question answering kind of tool, so you can actually solve stuff like that. So you know what this means? It means that actually Yan LeCun is right. Large language models are not reliable at all. I mean, recently he has this post that says that large language models generate a very factually incorrect output because the chance of a factually correct output diminishes as the context length increases, which is true because like, if you generate the right token, you need to get the sequence of tokens right all the way. So this is one of the flaws of the large language model. It's not very reliable. And my thought is that while it is not reliable, it can do flexible interfacing very well. So maybe in the future, we won't use large language models to do like reasoning and everything. We will use like a symbolic architecture, but we can use the ChatGPT or large language model to interface with this kind of architectures.
On that note, actually, I want to say something.
Yeah, please go ahead. Yeah.
So I agree that a vision modality in many cases are a better grounding than language model, but I think it's also not always the case, because you can also have things like optical illusion, which suggests that there are cases where your visual modality can also make mistakes.
Okay. I mean, yes. So as what I said,
I agree that multimodal is always better than just rely on single. It's same for human, right? If you're blind, of course you get less information from the world. If you're dumb, you get less information, right? It's the same thing. So it's always more. I believe it's always more modality the better, but it's not to say that visual is always superior than natural language. I don't think that's the case.
Yeah, of course. Yeah, so it really depends on what kind of inputs you can get and what's the kind of information you can extract from your inputs. And of course, like how well the output is dependent on how good your model is, as well as what kind of tools the model can use. So all these are the upper bound on what the model can actually output. Yeah. So I think you and I are on the same here, right? Yeah. Okay,
Yes,
so let's talk about some of the limitations because I have about 10 minutes left. I just want to wrap up this. Okay, so this while it's impressive that it can be an interface to tools, there are certain limitations that we still have right now. And one of the limitations is that it cannot go beyond the strength of the LLM and the APIs. I think this is something that even with many more innovations, this is still the fact of life. All right, we probably need to improve the APIs or the LLMs, or use a better system. But I would say that at least for now, my thinking is that the LLM can be the interface to a lot of good tools. It can create the Jarvis system like I meant, because it can act as the interface to all those tools. So this is something very cool. right? One other drawback is that it doesn't really learn very well because LLMs take very long to learn. APIs are kind of static right now. But if you can have the API to store like memory retrieval, like that kind of memory I was talking about in learning fast and slow, where you can, based on what you experience in real life, you store that as the memory, you do memory forgetting, and then you can retrieve those memory to kind of guide what the LLM should output the next action prediction. Maybe it can be adaptive. So this is something that could be done. I think a lot of promise holds in the kind of method that I was describing earlier in the learning fast and slow. All right. If not, actually this LLM plus API doesn't learn very well. It will be static. So it will be good for a lot of business use cases because in most of the time, you don't need the system to be adaptive. Like you want to use a calculator, you don't need the calculator to be adaptive, right? You just need it to calculate properly. So it's still very relevant for a lot of business use cases. It's just that in my own interests, I feel like adaptive learning systems are very interesting and I want to build it. So in my case, there's some limitations for this LLM and API, but it can be addressed. It's just not addressed yet, but this can be addressed. This is something I need to highlight, okay? While it can learn zero shot from a description of how to use the API, sometimes if the rules are too complicated, it may not be learned easily. Like for example, call the API only if the number is greater than 100. Okay, somehow it cannot compare greater or smaller. I tried it out. So stuff like that, you may not learn the rules easily. Okay, so if you say the rule is for calling like a person or place, like question answer API, it can learn zero shot very well. And that's probably why the Toolformer paper use it. If the rules are a bit more arbitrary, it can be difficult for the language model to learn zero shot. Of course, this can be like probably improved. Okay, if we can form some form of like logical inference for the model, but right now LLMs cannot do it. So maybe if you immerse it even more, I don't know, yeah, they can do it. But just bear in mind that if the rules for the API is too complicated, it may not be callable. Like Wolfram Alpha, some use cases, it may not call Wolfram Alpha like for DNA nucleotide sequences, although Wolfram Alpha can actually interpret DNA sequences. So because there's just too many use cases to call Wolfram Alpha for. So it's some stuff like that. This is one of the key things that I think needs to be focused on, because when you call the API, you give it zero shot kind of prompting. All right, you kind of need to keep prompting it after a while, because like maybe after 32,000 tokens, you reach the context length of the GPT-4, you kind of need to prompt it again. So if you have 1 million tools, right? Imagine you have 1 million tools that you need to describe the input-output relation for, you will have problems. All right, one way to solve the problem is to call it iteratively. Like you call for one cell API, you give the prompt, then give the prompt again for another set of APIs, and then you do it iteratively. Okay, it's possible. What will be a problem is, of course, the money, because all this description of the API tool takes up token length and you need to pay OpenAI for all this. All right. And the more severe thing is that, if you want to use this kind of APIs, like multiple API calls and everything, if the chain of API calls are too long, okay, it might not even fit the 32,000 context length. So we might need to increase the context length if we want to use like really a lot of APIs at the same time, or in a long sequence. So this is one of the, I think this is a very, very severe limitation, especially if we want to interface it with a lot of APIs. Okay.
So just to clarify, the max token length you're talking about is for one instance or input, or your entire dialogue?
The entire token length of, because transformers, they only can attend to a certain X number of tokens in the memory, in the dialogue history. Yeah, I'm referring to that token length of the input, because the transformer input is parallel, you see. So the token length is whatever you can attend to. Yeah, it's basically the same token length as ChatGPT. Yeah, nothing's changed here. It's just that with tools, you need to specify how to use it, so that will eat up the token length. Okay, I'll move on. So this is a failure case. So I asked it to do like a fact check API whereby you can call the word without any vowels. So this was done using ChatGPT. So you can try it out also. So I give it some example in the Toolformer way, like fact check XYZ, fact check JKL, which means that all this doesn't have any vowels in them. All right. So I gave it a sentence like that. What you need to do is you need to fact check because HMM has no vowels, and you need to fact check T as well. But you can see over here what the output is. What do you say? Fact check which is wrong, because like this is supposed to be T over here. Okay, and T doesn't need fact checking as it contains a vowel. So this is actually inherent in the case of like how GPT is trained, because when we do tokenization, we actually don't tokenize at the character level. We tokenize at the subword level, which is like byte pair encoding, you know. You use byte pair encoding, you chunk certain characters together. So it may not interpret character level stuff very well. So like, for example, what do you say T? It may not know that this is a T. It might have chunked them together with the question mark, you know, stuff like that could interfere with like how it responds to this kind of rules. Like this is a character level rule, which is like a word without any vowels. So these are some failure cases that might happen if your API is very specific like this. Okay, so
wait, how do you build the API? This is the OpenAI portal, right? The web
yeah,
page.
basically you just key in this as text.
So you don't really have a real API to call, right?
There's no API to call.
Okay.
Yeah, I'm just using this to see whether or not LLMs can interpret and like come out with the right inputs for these tools. So this tool is my own arbitrary tool that I just define myself.
Okay, I see.
Yeah, so I'm now using the Visual ChatGPT way of defining again. So like you have access to the following tools, your output, the tool as part of the original text, and this is just the formatting. So I give it the tools like just name, usage, input type. Okay, I don't even need to tell it like what are the examples. Like word check checks any word which does not contain a vowel. Number check checks any number above 100. Memory check checks any person or location. So over here, you can see that this is such a great day in London, XYZ. So this is the input that I want it to do. So over here, it did a memory check for this, okay, which is actually wrong because I guess this can be considered a location. So maybe if you do some form of like, I don't know, if you do something to do with the, like some examples, maybe it can do it better. All right, then we have stuff like memory check. So this memory check A, memory check grade, which is also wrong because is not exactly the location. Grade is also not a location. All right, London, yes. So maybe in this case, you know, you might need to give it some examples. Okay, we have memory check XYZ, which is also wrong. I guess XYZ can be a location, so I don't fault it. But I expected it to do like word check because like XYZ here. So you can see that the earlier case of the vowels, but you know, it can be seen that it doesn't do it well here as well. Number check, you see, it does number check for 38 and 365. But over here, it's always be above 100. So, you know, if your rules are kind of like those kind of comparing kind of rules, it may not get the stuff well. So like memory checks indeed, this one is correct. So I guess over here is also miss out this degrees Celsius. Is C is always be like no vowels. So this is a kind of example of a failure case of when you use tools and your rules are very difficult or it conflicts with the way like transformers work because they don't do character level or like they don't do comparison of numbers very well. You know, if it hits the weak point of a transformer, you cannot use the tool effectively. So these are the kind of limitations. So what you hear from me today, you cannot find anywhere else because I haven't seen any other source that talks about this. I was playing with it. I realized that there are some drawbacks for this tool integration. So I just want to highlight over here, it's not exactly like a wonder solution, you know. Sometimes it actually can fail. So these are some of the examples. Yeah. So I will end here today, okay, because I got to go. But we'll talk more about this maybe next week, like how we can improve on the way LLMs process, like hierarchically recurring, and also like we can then discuss a bit of like how to use tools and LLMs. So we just end here for today. Yeah. Thanks for coming. Yeah. Sorry, I cannot continue this because I've got to go. But as a concluding note, I'd just like to offer that like transformers, okay, it's a very versatile architecture. It can use it to interpret human intents. All right. And let me just go back to the starting slide. You can use it to interpret human intent. And if your human intent can be interfaced well, like the inputs to the tools can be done in a way that the transformer can interpret, like not at the character level, not to compare numbers, you know, stuff like that. Okay, if you can do it in a way that the transformer can pass it to the tools easily, all right, then it can form a very good interface to convert human intents to the tools. And then the tools can carry out the task and then pass back to the transformer. So this is like a huge step ahead for a transformer because it does quite poorly at stuff like math and so on. Yeah, and recently there's been some tools that can use it. You can use those tools to send Twitter messages, check your email, and so on. So I think it's quite exciting what the future will hold. And yeah, I'll end it here today. Next week we can talk more about the discussion. I'm sure you'll have a lot to talk about it. Okay, thank you.
Thank you, Changmin. Thanks, John.